Binomial probability is a specific type of discrete probability. It's countable, and there are 4 rules that are associated with it that you have to know. First of all, there can only be 2 outcomes called success, P, and failure, 1 minus P. So like maybe heads and tails. Either it happens or it doesn't. Each outcome has got to be independent. That means that the next time it occurs is independent of the previous time. For again, another example, flipping a coin. There's n set trials. I flip the coin only 4 times. There has to be a set amount. Can't keep on going. And the probabilities do not change. So for a coin flip, if it's 50-50, it stays 50-50. Now we're going to have several variables involved if you notice. We're going to have n is the number of trials. X is the number of successes. So maybe 3 out of 8 coin tosses are heads. So 3 would be X and 8 would be N. P is the probability of success. And 1 minus P, sometimes it's called Q, is the probability of failure. Now, what equations do you need to know? Well, the mean, the expected value of a probability distribution that's binomial for mu is just going to be n times p. One example I can say out loud, if you flipped a coin 4 times, I would expect 2 of the times on average to be heads, because that's 4 times 50%. Standard deviation, sigma, is going to be the square root of n times p times 1 minus p. Now, overall, if I want to find the probability for a binomial distribution, the probability of x successes happening is going to be what's called n choose x, p to the x, 1 minus p to the n minus x, where n choose x is actually the number of combinations. The actual formula for it is n factorial, x factorial, n minus x factorial. Again, this right here is used for the number of combinations. So again, something like I flip a coin 8 times. How many ways could I get 4 tails? That's how I figured out here. That'd be 8 choose 4. Most calculators, scientific graphing, will have some NCR button where you'll input those values before and after, and it'll go ahead and give you the answer without even worrying about factorials. But if you are worried about factorials and forgot what's a factorial, so 4 factorial. So this isn't 4, like, no. Factorial is you multiply all the way down to 1. 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 0 factorial, one that you do need to remember, is just equal to 1. So we're going to apply this to the following scenario. The chance of kicking a field goal in any football game overall has a 35% chance. So the probability of successfully kicking and making it is 0.35. Each kick we assume is independent of each other, and 5 field goals are kicked. So we have n set trials. The probability of success is 0.35. What is the mean and standard deviation of this distribution? Well, this distribution is binomial. There's only 2 outcomes. Either they make it or they don't. We're assuming the chance is the same overall each time. Each kick is independent, and there's 5 n set trials. It doesn't have to say binomial. You have to recognize if it's binomial. One of the big giveaways is they only give you a single percent, and they give you a single value in total. Okay, that's one thing to look for. The mean overall, mu, is n times p. So 5 times 0.35, that means I'd expect for every 5 field goals, I would make 1.75 of them overall. For the standard deviation, the square root of n times p times 1 minus p, break out that calculator, and then you got the square root of 5 times 0.35 times 0.65. That was 5 times 0.35 times 1 minus 0.35 will give you about 1.07 to 2 decimal places. How many ways can 2 field goals be kicked? Basically, how many can they be made? That is the whole 5 choose 2. That is 5 factorial, 2 factorial, 5 minus 2 factorial. So if you actually have to work this all out, that's 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 5 minus 2 is 3 factorial, which is 3 times 2 times 1. Write it all out. Like if you have 10 factorial, write out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then cross off. Gone, gone, gone. 20 divided by 2 will be 10 different ways. Again, in a calculator, you might be able to do 5 NCR 2, and get that as well. And lastly, if you're curious what the 10 ways are, if you have 5 field goals and you want to make them, 2 of them, then that'd be maybe attempt 1 and 2, or 1 and 3, or 1 and 4, or 1 and 5, 2 and 3, 2 and 4, 2 and 5, 3 and 4, 3 and 5, 4 and 5. If you add those all together, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways. That's the combinations. You could get 2 out of 5 field goals. Again, 2 field goals made out of 5 attempts. Although I don't expect you to write out all those combinations, but there they were. Finally, what is the probability of kicking 2 field goals out of 5? So that's the probability of getting 2 of these. I'm using this formula back here, right up here. Okay, ready? This would be 5 choose 2, 0.35 to the 2, 1 minus 0.35 to the 5 minus 2. Now let's clean up that last piece. 1 minus 0.35 is 0.65. And 5 minus 2 is 3. Okay, if you just want to know the formula, that's great. If you want to understand it, this is the way that I actually read this. There are 2 out of 5 ways where 2 I make and 3 I don't. Go back and listen to that again. That's how I remember this process. Now 5 choose 2, I already found it was equal to 10. So in your calculator, you're going to go 10 times 0.35 to the second power times 0.65 to the third power, and get a probability of 0.3364 to 4 decimal places. That is how you work one of these problems out. Now, it was nice that part B helped. If I didn't have part B, I would have had to done all this in blue in part B to get the final part for C. Last one, part D. What is the probability of kicking at least 1 field goal? At least 1. That goes back to one of those extremes. All, none, or at least 1 is 1 minus the none case. So if the probability of kicking a field goal is 0.35, the probability of not kicking a field goal is 0.65, and that's 1 minus 0.65, and we tried to kick it 5 times. You don't even need to use a binomial probability here because there's only one way that would occur. What's the only way none would occur? It means you didn't make it, didn't make it, didn't make it, didn't make it, and didn't make it, and that's really not cool. So it'd be 1 minus the none case. So there you go, dealing with probability, mean, standard deviation, combinations, probability, and remembering in those extreme cases, all, none, or in this last case, at least 1, you're not really using the binomial distribution here, but remembering the rules for those extreme cases.